Definite integrals. You can calculate an integral between two limits, seen as these two little numbers, and this is called a definite integral. A definite integral produces a value, and this value will either be positive or negative, whereas an indefinite integral always produces a function, as you've seen previously. So, looking at this example, we want to integrate between 2 and 1 the function 3x squared with respect to x. So adding 1 to the indice makes x cubed, and 3 divided by the new indice, so 3 over 3 is 1, so we're left with x cubed, and the limits are 2 and 1. And then we take the 2 and sub it into the x, and then we take the 1 and sub it into the x, subtracting the second from the first. So 8 take away 1 leaves 7. So just a reminder of that. The 3 stages: write out the integral, including its limits, integrate. Now we tend to use square brackets here and writing our limits at the far end, and then we fill in each limit into our integral and tidy up to get our answer. So here you can see in general the formal notation. Now let's look at examples. Example 7. Here we're being asked to integrate between 1 and 0 the function x to the power of a third minus 1 squared. So the first step here is to actually expand out that bracket. For most people, you will find it best to actually write out the bracket twice. This avoids any careless mistakes. So this is now equal to, expanding this out, x to the third times x to the third is x to the 2/3. And then minus 1x third minus another gives us minus 2x to the power of a third. And finally, minus 1 times minus 1 is positive 1. So now we're ready to integrate. Because this is a definite integral, we're now going to use square brackets. So I add 1 to the indice, so 2 over 3 plus 1 makes 5 over 3. And 1 divided by that is 3 over 5. Of course, you can use your calculator to help there. Then we have x to the third, adding 1 makes that 4 over 3. And then we have minus 2 divided by 4 over 3, which is the same as 3 over 2. And again, you could use your calculator to check that. Plus x. Filling in our limits, 1 and 0. Now, certainly at this point, we're now ready to fill our limits in. And a good exam technique would be to actually show these limits being filled in. And it may be a bit tedious writing this out, but it is showing clear method. So we fill the first limit in. On the second one, it might be a bit more obvious that if we fill 0 in, this is 0, this is 0, and this is 0, giving us a total of 0. Now all we're left to do is actually calculate this result. And of course you can use your calculator to help here. You may already have spotted, well, 1 to the power of anything is just 1. So we have 3/5 minus 3 over 2 plus 1, which gives 1 over 10. And that is our answer. Now, moving on to example 8. In example 8, we're given that p is a constant, and we're given an integral, a definite integral, and we're given the result of it. So this is more like a problem-solving question. So let's start. I want to integrate between 5 and 1, 2px plus 7, and I know that that is equal to 4p squared. So integrating the left-hand side gives us x squared, 2p divided by 2 is just p, plus 7x with our limits 5 and 1, and that's equivalent to 4p squared. Now let's look at the left-hand side. So filling our limits in. So this is going to be p times 5 squared plus 7 times 5 minus, and then filling the 1 in. And again, that is equal to 4p squared. So we're now left with 25p plus 35, and from that we're subtracting p plus 7. Noticing here, keeping my brackets, so I'm being careful because this minus will apply to both terms. So we have 25p plus 35 minus p minus 7 equals 4p squared. So this is starting to look like we're trying to solve a quadratic equation. So just tidying this side up, we have 24p plus 28 is equal to 4p squared. And at this point we can probably spot that 4 divides into each term. So we're left with 6p plus 7 is equal to p squared. Tidying that up, that gives us p squared minus 6p minus 7. And factorising gives us p plus 1, p minus 7. So therefore, we can see that p plus 1 equals 0, or p minus 7 equals 0, giving us that p is equal to minus 1, or p is equal to 7. And we have our answer.